SLIM. Sustainable low-impact mining. Results and innovations impact on industry and society. The SLIM project aimed to help make especially small-scale mining in Europe more effective and sustainable. The final goal was to ensure the economic viability of the mining processes by developing cost-effective and sustainable, selective, low-impact mining solutions.
The SLIM approach is to inject state-of-the-art techniques into the mining operation by developing tools to control the excavation phase, fine-tune the processing plant, and reduce the environmental effects in order to improve feasibility, profitability, and social license of difficult mines.
The consortium looked in detail at the way the rock mass behaved as a result of the use of explosives.
SLIM guarantees a better use of the explosive and a more efficient blast design based on rock mass characterization and numerical and analytical models for rock fragmentation.
Innovations achieved are a procedure to analyze readings provided by drill rigs so as to characterize and classify the rock mass. Procedures to assess the mechanical condition of the rock mass based on LiDAR and photogrammetry tools. The use of optical televiewers to determine post-blast rock damage as an alternative to the indirect method used in the past. Joint mapping of the rock mass based on photogrammetry, LiDAR and optical televiewer records is of great importance in optimizing the blast design.
We have developed a tool to obtain the in-situ block size distribution of the rock mass.
SLIM investigated new explosive technologies to make blasting safer, more efficient and sustainable. SLIM developed a new bulk emulsion explosive and a delivery system so that each blast hole can be loaded with explosives of differing density, energy and viscosity.
This new explosive formulation can help mine to work with minimal environmental impact by controlling the nitrate leaching contamination, but at the same time they can deliver the right energy for rock fragmentation in heave, which has a positive impact in downstream operation. Associated with a powerful blast design software simulation, they can improve their operation from both environmental point of view but also from economical point of view.
SLIM developed new automatic blast design software aligning the boreholes according to the geometric situation of the bench face. Another innovation is the muck pile characterization software for analyzing the result of a blast. This software uses new approaches based on artificial intelligence.
These new software components allow us to optimize surface blasts, and therefore we reduce environmental impacts, we reduce explosives consumption, and we get more results from the rock that is blasted to be used afterwards.
SLIM also sought to offer modern explosive techniques to raw material extracting industries to decrease the environmental footprint while maintaining safety and productivity.
So far we achieved a geophysical and topographical model of the mine where we exactly know the speed of the vibrations going from point A to point B, and with this topographical model we are also able to forecast the vibrations of a specific blast. For dust we achieved a near-field model around the blast site. With this near-field model we also came up with solutions for suppressing the dust with lining, for example with water or special eco-friendly chemicals who are suppressing the dust.
To obtain a social license to operate, local communities and society in general must be involved in the development process.
Our work is important for the sustainability of mining activities because obtaining the social license to operate with the local communities of the mining sites will ensure its operation, avoiding costly delays, potential risks and even the closure of mining activity.
SLIM organized workshops at the local and European levels, leading to the elaboration of social awareness guidelines. SLIM also conducted an environmental life cycle and socio-economic cost-benefit analysis of the new technologies.
What happens with the project results once SLIM is over? We provide the appropriate framework for the characterization of the exploitable results emerging from the project. We also prepare them for the next steps. Some results can be exploited commercially, aiming at growth and job creation. Some go to the dissemination route, enabling other parties to make use and build on those results. And others can serve as basis for public policymaking. We work towards maximizing impact for future mining in Europe.
SLIM mainly focused on smaller mining operations. What are the operators saying?
The SLIM approach is really important, that the mines and the quarries will be able also in the future to do their operations close to vicinities, close to towns and close to cities. Therefore, the SLIM project is really important for us as a mining community.
The main task for us is to optimize the drilling cost and the processing plant costs. And so we expect to reduce the cost of our general operation thanks to the SLIM project.
The SLIM partner, Minere de Oshiba, is an example of how an operation can grow with better rock excavation technologies and mine-to-plant global assessment. Production at Sierra de Luja mine has been nearly doubled through the profitable mining and processing of ore with substantially less yield, from a cut-off grade of nearly 40% fluorite to one of 20% by the end of the project. This has resulted in an increase in reserves of an as-yet unknown amount, but likely more than threefold, and an extension of the life of the mine of at least 50 years. The social impact of increased production is extremely positive, with more jobs and sustained wealth in the area for a couple of generations. SLIM proved to be highly successful at improving especially small-scale mining in Europe. Thanks to SLIM, mining operations will become more effective and sustainable and will develop better relations with neighbours. Follow us on www.slim-project.eu and on Facebook and Twitter.